Hello everyone, welcome back to my YouTube channel. As you all know, I am Bhumika, student of Sri Venkateshwara College of Engineering, Bengaluru, from the Department of Computer Science and Engineering. Today's subject is Applied Physics. Today I am going to explain the topic of creation of animated characters by the application of physics. Today I will be explain about introduction, types of animation, application of animation, basic principles in animation, steps for creating realistic physics, simulation in 3D creation. Introduction. Creating animated characters with the application of physics involves simulating realistic movements and interactions based on the principles of physics. This process enhances the believability and naturalness of character animations. Physics based animation typically involves rigging and skeleton setup, mass and inertia, joint constraints, gravity and external forces, collision detection and response, ragdoll physics, inverse kinematics, simulation techniques, animation controllers, and iterative refinement. Next, types of animation. In animation, there are five types are there. These are traditional animation, computer generating animation, stop motion animation, 2D vector animation and motion capture. Application of animation. Those are entertainment, movies and TV shows. Animation is a fundamental part of both traditional and computer generated films as well as animated series. Video games. Animation enhancing the gaming experience by bringing character and environments to life. Advertising. Commercials. Animated message advertisements can be eye catching and convey messages creatively. Digital marketing. Animated content is used in online companies, social media. Education. E learning. Animation makes educational content more engaging and helps in simplifying complex concepts. Training simulations. Industries use animations for training simulations, especially in fields like aviation and healthcare. Medical illustration. Animation are employed to illustrate medical procedures, anatomy, and biological processes for educational and institutional purposes. Architectural visualization. Message. Animated walkthrough and flyovers help architects and designers present their concepts and design more effectively. Simulation and training. Industries such as aviation, military, and healthcare use animation for simulating scenarios and training personnel. Virtual reality and augmented reality. Animations enhance immersive experiences in VR and AR message applications, from gaming to virtual tours. Web design and user interface. Animated elements in web design and UI or UX enhance user interaction and create a dynamic user experience. Animation controllers. Develop animation controllers that blend physics based animations with artist created animation for precise control. Iterative refinement. Continuously refine the simulation parameters based on visual message feedback, adjusting mass, damping, and other factors to achieve desired results. Principles of animated videos. Time spacing and scale, law of inertia, weight gain and loss, action reaction, momentum and forces, center of gravity. These are the principle of animated videos. Let us discuss briefly about this principle of animated videos. First, law of inertia. Law of inertia is the resistance of any physical object to any changes like starting or stopping a motion or changing direction. Second one is time spacing and traveling. Spacing is the distance an element travels between two frames of an animation. Timing is used in animation to produce motion that adheres to physics rules and adds interest. Fourth is action reaction. The principle of action reaction, also known as Newton's third law. When a character interacts with a character direct with an object, both are affected. And the fifth is momentum and forces. The principle of force and momentum says that an unbalanced force will change an object's momentum. The bigger the force, the quicker the momentum changes. For moving characters, this change in momentum could result in increasing or decreasing a character's speed, or it could be a change in direction. Sixth is center of gravity. The center of gravity is the average location of an object weight. The center of gravity is important for various reasons. The path of action of a moving character, the point what we are most interested in tracking is the center of gravity. Steps for creating realistic physics simulations in 3D animation. Choose the right software is the first step. The first step to creating realistic physics simulations in 3D animation is to choose the right software for your needs. There are many options available. The second step is set the parameters once you have chosen your software. You need to set the parameters for your simulation. These are the values that determine how your simulation behaves and interacts with other objects and forces in your scene. Some of the common parameters you need to add: mass, friction, gravity, collision. Third step is optimize the performance. Creating realistic physics simulations in 3D animation can be very computationally intensive and time consuming, especially if you have complex or large scale simulations. Therefore, you need to optimize the performance of your simulations to reduce the render time and the memory usage. Fourth step is add details and variations. One of the challenges of creating realistic physics simulations in 3D animation is to avoid making them look too uniform or artificial. To add more realism and interest to your simulation, you need to add details and variations that reflect the natural diversity and imperfections of the physical world. The last step is review and refine. The final step to creating realistic physics simulations in 3D animation is to review and refine your simulations until you are satisfied with the result. Thank you for watching my video. Please do like and subscribe to my YouTube channel.